This video demonstrates TransSiP PI power integrity technology in a real-life GPS application. In this video, we are looking at screens of two identical golden reference GPS receivers being tested side by side with weak satellite signals. This is representative of so many real-world situations where the signals are weak. It could be due to small antenna in a compact design, blockage by buildings, hills and trees, and there is, of course, multipath fading caused by reflection. This test setup was carefully designed to make sure both units were tested under same conditions. The readings on the right demonstrate the effect of TransSiP PI technology. The control unit, shown on the left, is powered in accordance with the current industry best practice. Low-noise linear regulators, known as low dropout regulators or LDOs, are being used. Currently, the LDO is regarded as the de facto standard for powering noise-sensitive GPS receivers. It is thought to provide the best power supply noise quality to the system, even though LDO is poor in power conversion efficiency for low-power systems. Both receivers are running with the same firmware version connected to the same noisy power source, which is a standard 5-volt USB port. There is just one antenna shared between the two test units by a power splitter. Both receive exactly the same satellite systems at the same time. The cable loss is carefully managed, making sure there's no more than 0.5 decibel variation between the two units. Both test units were stationary, and the playback on the black screens at the top shows the positioning coordinates reported by the GPS receivers every second for 24 hours. You will see clearly that the errors shown by the PI-powered unit on the right are much less than those of the best practice units on the left. The map below the active plot shows the final results. These demonstrate that the actual positioning errors under weak signals can be massive, as much as 2.5 kilometers. In fact, they're as large as the airport runway shown on the right of the plot. This is not uncommon in GPS navigation. You've probably heard on the news how a car was guided into a lake and another into a railroad. Under exactly the same conditions, the TransSiP PI-enabled unit on the right shows positioning errors that are 10 times smaller than the supposedly golden reference on the left. The errors are reduced from 2.5 kilometers right down to only some 200 meters. The histograms on the right of the coordinate plot show the strength of the signals actually received. Signal strength will, in fact, be the same for both sides. However, the left-hand histogram shows many more blue readings indicating system dropouts with the weak signals. The PI-powered system on the right is able to maintain stability with the same weak signals, providing continuity as well as much improved accuracy. TransSiP PI technology adds stability to the system, ensuring it is less influenced by noise and improving its ability to process weak or noisy signals. The system's performance is much improved and the algorithm runs much smoother and faster. The hugely advantageous of PI on GPS can be applied across the board to all other noise-sensitive applications. A TransSiP PI certified product includes an assurance to customers that products meet rigorous requirements in both energy efficiency and performance, which are above average industry standard. Products certified by PI technology will come with a certificate and the TransSiP PI logo to be displayed. To learn more about TransSiP PI, please visit the website at transip.com.